Hello everyone, good evening. Welcome to the Premier Wednesday event. I'm Anusha from the Premier Agile team. Premier Agile is a leading provider of Scrum Alliance certifications. We help with the certifications like CSM, CSPO, Advanced CSM, Advanced CSPO and AI courses. We have trained more than 25,000 plus professionals by conducting 1,000 plus workshops globally. Our sessions are known for being interactive, experimental, and based on brain science learning. Agile is our main focus, but we also love to build communities and learn about other interesting topics. That's why we started Premier Wednesday, a weekly sessions where experts from different fields come and share their knowledge. And apart from Agile, we have also covered some amazing topics in the past, like professional branding and AI in aerospace. Today, we have a very exciting topic space tourism and exploration, something that was once just a dream, but now it's becoming a reality. We are glad to welcome Siddharth Konduru, who is currently in his third year of aerospace engineering. He is passionate about space and will take us through the exciting topic today. So get ready. This is going to be an exciting session. Thank you, everyone. Over to you, Siddharth.
Thank you, Anusha. Good evening, everybody. My name is Siddharth Konduru, and I'm a student of RV College of Engineering, third year of Aerospace Engineering branch. So, some of you might have already attended my previous webinar, which I did about almost a month back, and I discussed the applications and future of AI in aerospace. And I'm glad all of you have taken the time to attend today's webinar as well. Just goes to show how many of you are actually interested in the aerospace field, and I'm all for it. So, of course, I'm also grateful to Premier Agile for giving me this opportunity to spread my knowledge on the aerospace field once again. Anyways, today's topic we'll be discussing about space tourism and exploration. I'm sure some of you people when you were little kids you must have dreamt of going into space, and you might have thought of space as this mysterious place that had mysterious objects circling a burning fire of circle. So, of course, all of us must have only read about this in books and articles, and none of us have actually been in space. So, it's obviously just a natural human tendency to want to see something that we know exists but is hard to reach. Well, this webinar will be discussing about how space, one reserved for astronauts and elite scientists, is now becoming accessible to civilians, entrepreneurs, and private organizations. And I'll be walking you through how space travel is evolving, what companies are leading the shift, of the opportunities, risks involved, and where India stands in all of this. So let's move on to this. So here are the table of contents. So this is what we'll be covering today. We'll of course start off with the basics by defining what space tourism really is, and then we'll dive into the history, the key milestones in space evolution. Then we'll talk about leading companies driving this transformation, the actual benefits of space travel beyond just thrill and adventure, the current challenges, India's growing role, and the future scope as well. We've got a lot to cover, so let's jump right into it. So, first, let's start with defining what space tourism really is. So, space tourism refers to commercial space travel by non professional astronauts for either recreation, business, or education and adventure. So in short, it's regular people going to space. So now there are three subcategories that come under this space tourism. So we have suborbital flights. These go just past the boundary of space around 80 to 100 kilometers above the surface of Earth. So passengers experience weightlessness for 3 to 5 minutes. And the Blue Origin's New Shepard rocket is a good example of this. Also, Virgin's Galactic space plane as well. So it's the second one will be suborbital flights. So these just go past and the orbital flights, second one, my bad. So these kind of flights are much more demanding. Passengers circle around the Earth's orbits for hours or even days. An example is SpaceX's Crew Dragon, which has taken civilians to the ISS or the International Space Station. The third one is lunar and deep space trips. So in this type of trips, it's not just about visiting, but also about to aim to orbit or land on a celestial body. For example, Dear Moon by SpaceX, It was planned for 2026 to 2027, which involved orbiting around the moon, but was ultimately, unfortunately, cancelled due to the delays in the Starship development. Suffice to say, this type of flight is still under development. But before we talk about where we are going, let's take a moment to understand how we got here. So let's talk about the history of evolution of space tourism. Go to the next slide. So, of course, space tourism didn't just pop up overnight, right? It took years of scientific and technological progress and advancements. So, let's have a quick look at the timeline. So, during 1960s to 1980s, space was fully government run. So, NASA's Apollo program, USSR Soyuz mission, this was all the Cold War space race. Only trained astronauts went to these kind of missions. So, in 1990s, the Cold War started to end. There were budget cuts and excess capacity in Russian missions. This opened the door to private individuals to space. In 2001, Dennis Tito is the first paying space tourist. He's an engineer and an American entrepreneur. In 2004, Virgin Galactic, which is a company, announces plans for commercial suborbital flights using air-launched space planes. From 2010 onwards, SpaceX enters the scene with reusable rockets, which, as the name suggests, are designed to be used more than once, unlike traditional rockets. And Blue Origin and other companies follow in this vein as well. In 2021 is actually considered to be a year of many milestones because SpaceX launched the Inspiration 4 mission, which was first all civilian uh, orbital spaceflight. So Blue Origin also sends Jeff Bezos above the Kármán line. So Kármán line is an imaginary boundary 100 kilometers above the Earth's surface that is widely considered as the division between Earth's atmosphere and the outer space. And then Virgin Galactic also carries Richard Branson, who is its owner actually. It's into outer space. Of course, this shift wouldn't be possible without the pioneers leading the charge. So we'll take a look at the key players that make space tourism a reality. Let's move to the next slide. Okay, so some of the space companies that are leading the development of space tourism, whose names have already mentioned in the previous slides, but we'll go into a little bit more detail here. So SpaceX, as you know, it was founded by Elon Musk, and it is famous for its reusable Falcon 9 rockets, which I mentioned earlier. The Crew Dragon capsule has taken civilians into space, and their Starship rocket is being designed for Moon and Mars missions. Their goal is to make humanity multiplanetary for the foreseeable future. And then we come to Blue Origin. So Blue Origin is a company that was founded by Jeff Bezos. It operates the New Shepard flight, a vertical rocket for suborbital trips. It focuses on gradual development with full reusability as well. So its goal is more heavy industry to space and keep the Earth clean. So that's its goal. Then Virgin Galactic. So Virgin Galactic was founded by Richard Branson, as I stated earlier, and it uses a carrier aircraft to air launch a space plane. So it's a little bit less intense than a rocket, and it's more tourist friendly. And it offers 90-minute suborbital experiences. So now that we know who's building the rockets, let's explore why this matters beyond just taking civilians to space. So we'll be talking about the benefits of space exploration in the next slide. So let's talk about the benefits. So you might be wondering why spend millions of dollars just to go to space. The obvious answer is for the adventure and thrill of it, but there are other real benefits as well. So for example, benefits that impact science, technology, innovation, education, and even the environment. So innovation. Every tourist flight is a test platform, right? When companies like SpaceX or Blue Origin prepare to carry civilians, they need to make things simpler, safer, and more automated. So that drives innovation across the board, from lighter spacecraft materials into smart life support systems and autonomous navigation. So let's think of it this way. So if iPhone was developed only for NASA, we wouldn't have touch screens in our pockets today, right? So similarly, these tourist flights will drive breakthroughs that trickle down into aviation, medicine, material science, and energy. The second one is tourism revenue will help fund more exploration. So Does anybody have any idea how much a ticket to the space costs, regardless of the company which you're in, which you're buying from? You can feel free to answer. Does anybody have any idea? I mean, I'll tell the answer anyway, so you can just take a random guess.
$50,000.
Okay, that's very close. It's actually for Virgin Galactic, it is $45,000, which is pretty close to what he said. And for SpaceX, it's about $55 million, and it injects privacy money into the space economy. This reduces reliance on government budgets and frees up public agencies like NASA and ISRO to focus on deep space missions. So the third advantage is inspiration on STEM education. So there's a very real and often underrated benefit here, the psychological impact on young people. So when they see a civilian, not an astronaut, maybe a teacher or an artist, floating in space, they start thinking, maybe that could be me someday. Well, that was certainly me. That is incredibly powerful, and it inspires students to pursue careers in science, engineering, mathematics, robotics, intelligence, and even aerospace engineering. And these are the fields that build up the future. In fact, after the Inspiration 4 mission in 2021, Google searches for how to become an astronaut has spiked by about 300%, which is just crazy, isn't it? The fourth advantage is Earth's observation and climate monitoring. Now, most people don't associate tourism with data collection, right? So these tourist missions are not just joyrides. They're equipped with cameras, sensors, and monitoring devices that help track environmental changes on Earth. So you can monitor stuff like, for example, deforestation, ocean temperature and current, ice cap melting, air quality and pollution levels. Some companies are already planning to combine tourism with climate research, where you could fly to space while also contributing to the global environmental data. So these are some of the basic benefits that are involved with space exploration and tourism as well. But every opportunity, of course, comes with its own set of challenges, right? And space tourism is obviously no exception. So we'll be discussing about the challenges that are involved in the next slide. Let's move on. So let's talk about the challenges. So far, we've seen how space tourism is promising, exciting, and inspiring. But what's holding it back? The reality is we're on the edge of the space revolution. There are still significant challenges that stand in our way in way of making it mainstream, safe, and sustainable. So the first and foremost, and obviously probably the most obvious challenge is safety, right? So the inherent danger of space travel cannot be ignored. We're dealing with extreme speeds, massive energy, and unforgiving environments. In orbit, even a small piece of space debris, something the size of a screw, can hit you at a speed of 28,000 kilometers per hour. That's faster than a bullet and could punch through the spacecraft wall. It's not just theoretical, by the way. In 2003, the Columbia space shuttle disintegrated during re-entry, killing all seven crew members. In 2014, a Galactic test flight. It broke apart mid-air, killing one pilot and injuring another. Now imagine civilians, ordinary people, with no military or astronaut training going up there. The bar for safety suddenly rises exponentially. SpaceX and Blue Origin have worked hard to automate many safety systems, but there's still a long way to go. The second one is cost, which we have already discussed earlier. So right now for Virgin Galactic, it costs about $45,000, and for sorry, my bad, for $450,000, and for orbital trip with SpaceX, it would take about $55 million, as I discussed earlier. And that obviously limits people who can go. It's limited to billionaires, celebrities, and ultra elite scientists. So not regular people, basically. So prices are high now, but reusable rockets, mass manufacturing, and growing demand will eventually bring the cost down to thousands, maybe even hundreds in the upcoming decades. So the third one that has to be addressed is regulation. So this is something many people overlook. So space law is still a wild frontier. Who is responsible if a private rocket explodes and damages property? What happens to a tourist if he gets injured in the orbit? If a space tourist commits a crime on the space station, which law applies? These are some extreme examples, but right now countries like US have their own commercial spaceflight regulations. There's no unified legal space framework, and as more nations and private firms enter the game, from India, UAE, Japan, etc., this legal patchwork becomes even more complicated. So the fourth challenge that has to be kept in mind is the environmental impact. So this might sound a little bit counterintuitive. You would think space travel is about leaving the Earth, right? But every launch affects the Earth's atmosphere as well. So rockets emit large amount of CO2 and black carbon particles, especially into the stratosphere, where it stays longer and warms the planet. For example, a single Falcon 9 rocket launches as much carbon dioxide as a commercial airplane flying hundreds of passengers across the Atlantic. That's just the fuel, too. Some rockets, like the Russian Soyuz, use toxic propellants like hydrazine, which is extremely hazardous to the environment. And yes, the vision is exciting, but it's not without its hurdles. Safety, cost, legal regulation, and sustainability. These are not just check boxes to tick off. These are pillars we need to build properly if we want space travel to become a reality and space to become a regular destination. But the encouraging part is none of these challenges are truly unsolvable. We are already making progress. If we zoom out a bit, big space isn't only about sending tourists out, it's also about exploration. So let's talk about what lies beyond commercial flights, the deep space missions that push human limits. So beyond tourism, right? So some of the key and ongoing missions that go just beyond tourism are, so for Mars missions, we have NASA's Perseverance. So Perseverance primary mission is to look for signs of ancient microbial life. It landed in the Jericho crater, a region scientists believe once held a lake and river delta billions of years ago. If life ever existed on Mars, ever microscopic, this is where the evidence might still be preserved in sedimentary rock. So, Perseverance is collecting samples of Martian rock and soil, sealing them in tubes that a future mission will bring back to Earth, maybe possibly around 2031. So future missions are intended to return samples and send humans to Mars as well. And Elon Musk's SpaceX plans a Mars colony via Starship as well. Then let's talk a bit about James Webb Telescope. So James Webb Telescope was launched in December 25th, 2021, aboard on Ariane 5 rocket. It is orbiting around 1.5 kilometers away from the Earth, at the L2 Lagrange point. That is four times farther than the Earth is from the moon, right? So unlike Hubble, which mainly looked at visible and ultraviolet spectrum, Webb specializes in infrared, right? Well, why infrared? Because it can see through cosmic dust, like seeing through fog, for example, and it can observe galaxies so old, more than 2.5 times larger than that of the Hubble's, and they are made of gold coated beryllium, designed to reflect faint infrared light better than anything that we've ever built so far. The James Webb Telescope has accomplished the following. It has captured never before seen exoplanets and their atmospheres. It has found the most distant galaxy ever observed. It had the revealed detailed images of stellar nurseries, which is basically the place where stars are born. And then the moon, right? So NASA's Artemis program aims to establish a permanent base on the moon. One of the most exciting and truly historic missions in space exploration is the NASA's Artemis. So it's NASA's plan to return humans to the moon, and this time it is to stay. The program began with Artemis 1, which some of you might be familiar with. It launched successfully in November 2022. It was an uncrewed test mission of NASA's new Space Launch System, SLS, also known as, and the most powerful rocket in the world, and the Orion crew capsule. Next is Artemis 2. It is scheduled for September 2025. This is the first crewed mission of Artemis program carrying four astronauts around the moon on a lunar flyby. It will be the first time since 1972 that humans will travel beyond the low Earth orbit. If you don't know, there are three types of orbits. There are low Earth, medium Earth, and geostationary. Then the mission will serve as a critical test for life support, navigation, communication systems in deep space. So Moon is basically seen as a testing ground for deep space travel as well. Third one, where research is going on, is asteroids and exoplanets. So, for example, a good example would be the OSIRIS-REx mission. So they are collecting samples from asteroids. So OSIRIS-REx, it stands for Origins, Spectral Interpretation, Resource Identification, Security, Regolith. A mouthful, but in simple terms, it was a mission to visit an asteroid, collect a sample, and bring it back to Earth. Cyrus Rex was launched in 2016 and arrived at an asteroid called Bennu in 2018. So Bennu is a near-Earth asteroid that's about 500 meters wide. And interestingly, it's classified as potential hazardous object with a very small chance of hitting Earth in 2000 in 2100s, right? So if you're wondering about what the chance might be, it's very thin. It's very slim and thin. It's about 0.0037%, and it is predicted to hit about in 2184. But the probability of it hitting is very slim, as I just said. So after spending nearly 2 years mapping Bennu's surface, OSIRIS-REx successfully collected surface material in 2020 using a robotic car. It gathered over 120 grams of dust and rock, the largest asteroid sample ever collected in human history. So private companies even aim to mine the asteroids for rare minerals and metals as well. So with all that being said, so let's bring the spotlight back to home, right? Then let's talk about how India is stepping up as a powerful force in this global movement in the next slide. Okay. So a lot of people outside the India still think ISRO as a cost-effective satellite launcher. Well, that is true. We've launched satellites for over 30 countries. India's ambitions now go way beyond just launching contracts. So we are now stepping into the arena of space exploration, human spaceflight, and eventually even space tourism. Chandrayaan 3, or most of you must be knowing, very recently only it happened. It achieved something no other country has ever done. It has successfully landed in the south pole of the moon. Well, why does that matter? Because this region has permanent shadow zones. These are extremely cold areas that may hold water ice. And water means fuel, oxygen, and potential for a future moon base. It was really a proud movement for India, but more than just that, it is a geopolitical milestone. It showed the world that India is no longer just a junior player. We are innovating on a global level. The second one we'll be talking about is Gaganyaan, right? So on Gaganyaan, it was planned for 2026, and this will be India's first crewed space mission, sending 2 to 3 astronauts into the low Earth orbit for several days. The astronauts have already been shortlisted. They're all from the Indian Air Force. They're currently undergoing training in both India and Russia. Third one is Bharatiya Antariksh Station, India's own space lab. So looking even further ahead, India is planning to build its own space station, the Bharatiya Antariksh Station, by around 2035. And there are some private companies as well, not just ISRO. So Skyroad Aerospace is an example, becoming the first ever Indian company to launch a rocket, the Vikram S, in 2022. Unequal Cosmos is another company. It works on building customizable 3D printable rocket engines and launching from their private pad at SDSD, Sriharikota. Then Bellatrix Aerospace focuses on green propulsion and satellite systems. So India's ambitions are backed by cutting-edge tools and technologies. Let's explore what makes all of this possible, right? Okay. So let's talk about the first uh, tool and technology, which is reusable rockets. So this is probably the biggest innovation of 21st century in space tech, reusability. And SpaceX successfully landed a Falcon 9 booster in 2015. it changed the economics of space travel forever. Instead of throwing away a rocket after one use, which is like throwing away an airplane after one flight, we can now land, refurbish, and fly again. The second one is AI navigation. So today's rockets and capsules are very autonomous. SpaceX Crew Dragon, as I mentioned earlier, for example, can launch, orbit, dock, undock, and land, all without the intervention of a human being. This automation is key for space tourism because most passengers will not be astronauts, believe it or not. They'll need systems that are fail safe and user proof. The third one is advanced suits and crew habitats. We're also seeing big improvements in space suits and living quarters. Today's space suits, like the ones used in Crew Dragon, are all lightweight, fire resistant, integrated with biometric sensors. They monitor heart rate, oxygen levels, carbon dioxide buildup, and can respond to emergencies quickly and automatically as well. High efficiency propulsion. So we are testing out new ways of propulsion such as ion thrusters, which use charged particles and electric fields. They're very slow but incredibly fuel efficient. And then cryogenics engine as well. So they burn super cold liquid, hydrogen and oxygen, giving thrust with high efficiency. And then the fourth technology is inflatable modules. If space tourism takes off, we need orbiting hotels, labs, and even restaurants someday. So traditional metal modules are heavy and cramped, but inflatable space habitats like the Big Yellow P330 are light, expandable, and can house much more people with less launch costs as well. These are still being tested as we speak, and some are already docked into the ISS. So we'll move on to the next slide. So I've written a blog on space tourism that covers most of what I'm covering in this webinar, such as the basics of what is exploration in spaces, the leading companies, advantages, disadvantages, India's role in the space exploration, and then the future missions as well. So if you're still interested, if this webinar piques your interest, you can always check out that blog later if you want to know more. It'll be available in the Premier Agile website. And if all of this sounds futuristic, you don't have to wait long because many major missions are already under. Just give me a sec, guys. I'll just do more. Yeah, all that talking makes your throat feel really dry, and it's really difficult to continue talking after that. So it's important to take important sips of water in between such a long session. Anyway, let's move on to the next slide where we'll be talking about the future missions. So the upcoming mission. So before we wrap up, I want to first quickly highlight some of the most exciting space missions coming up in the next few years, which many of which will define both the future and future of both exploration and tourism as well. So as I discussed earlier, NASA's Artemis 2. So this will be the first crewed moon mission in over 50 years, part of NASA's Artemis program. NASA Artemis 2 will orbit the moon, test critical uh, life support system, and prepare for moon landing with Artemis 3 in either 2026 or 2027. Dear Moon, SpaceX. I've already discussed about Dear Moon earlier in this webinar and how it was unfortunately scrapped due to a delay in the Starship development. And then we'll talk about Axiom Space Station, another upcoming mission that's going to redefine human presence in space is the Axiom Space Station. Axiom Station won't just appear out of nowhere. They're building it in phases. The first modules, including habitation module, laboratory, and observation deck, will be launched and attached to the existing ISS. Once the ISS is retired around 20 to 30, Axiom modules will detach and operate independently, forming the world's first privately owned space station. And then Gaganyaan is something that is launched by India. So India's first human spaceflight mission is expected to go around in 2026. It will send 2 to 3 Indian astronauts to low Earth orbit and bring them back safely. And it is a historic moment in India's space leadership journey. And we'll talk about a little bit about SpaceX launches. SpaceX plans to launch over 170 launches in 2025 alone, from satellites to deep space probe to crewed missions. They're building the launch infrastructure of the future. And that was about some of the most exciting space missions that are upcoming in the foreseeable future. So with that, we can move on to the next slide, in which I'll be talking about the differences. So for those of you who want to read more, here are some of the sources I referred to throughout this presentation. So these include mission briefs from NASA, ISRO, and SpaceX, updates from companies like Blue Origin and Virgin Galactic, official data on India's space economy and infrastructure. So if anybody is interested, I'd be happy to share these links with you after this session. So, and that's it. With that, we've explored the landscape of space tourism and exploration, not just where we are, but where we are going to be. Thank you again for attending this webinar. If any of you have any questions now, I'll be willing to answer them. You feel free to just unmute yourselves and ask a question, or you can drop it in the chat.
Hello, Siddharth. That's a great session so far. I have a question
Thank you.
for you.
Yes, Nandan.
How can I help in space tourism?
Yes, Nandan, as I discussed earlier, so AI can significantly enhance space tourism by improving safety, efficiency, and obviously the passenger experience as well. So it can automate space operations. It can optimize the flight paths, and it can provide personalized service as well. So it makes space travel much more interesting and much more enjoyable, much more accessible as well. Any other questions from anyone else?
Data like clarification on.
Anybody else at all? Let's check the chat.
Hi Siddharth.
Hello, Akshara.
What is the difference between space tourism and space research?
Okay, and that's a question you got there. So space tourism, it focuses on recreational travel and to space, but space research, it involves researching scientific investigation in space. So space tourism is driven by commercial interests. It offers experiences like zero gravity and views of Earth from space for paying customers. But space research, on the other hand, it's just basically aimed at enhancing the scientific knowledge on space, and it involves experimentation, data collection, also the effects of space on various phenomena. So that's the difference between space tourism and space research.
Yeah, okay. Thank you.
Okay. Those are some good questions. So if anybody else any other question, we can. If not, then we can wrap it up.
Let's wait for more 2 minutes and we can look at that.
All right.
Thank you, Siddharth, for sharing valuable insights. To register for future Premier Wednesday events, you can visit www.premieragile.com. Thank you, everyone.
Just, I think there's something in the chat. Oh. So Nahid Anjum says, awesome session, your turn. Thank you, Anjum. Thank you, Himanshu and Aruna as well. Glad you all enjoyed the session. Okay. Revalla Akshara asks, what are the four forces acting on aircraft during flight? Well, Akshara, even though this is related to aeroplanes instead of spacecrafts, the four forces that act are lift, drag, thrust, and then weight. These are the four forces. So lift opposes the weight. Lift is what causes the aircraft to move upwards, and thrust is what causes aircraft to move forward. And the drag is something that opposes the thrust. So these are the four forces of an aircraft. Thank you, SRK. Thank you, Anusha. Thank you, Akshara and Nadia as well. The support means a lot. Yes, indeed, this topic is very interesting. And if you wish to dive further, you can obviously ask me for the kind of references that I've used, from where I have borrowed this information, and all that stuff. You can ask me for those references so that you can read for yourself. And you can also check out my blog on the Premier Agile website. Will there be another session? Reval Lakshar asks again. It depends, honestly. With the kind of support that I'm getting, I'm honestly inclined to do another session as well. So it really depends. Currently, I'm not free for the next 1 or 2 months, but maybe after that, I can find another interesting topic and do another session for Premier Agile. It all depends on the support of the viewers. So thank you all for supporting this. Okay, I guess that about ends this. Looks like we have another question. So, Rona Kumari asks, people say aerospace engineering is hard. Is it true? Well, certainly it is up there with with the hardest engineering branches. So, along with electrical. But honestly, if you got a passion for it, it really shouldn't be hard. And if you're doing something that you're interested in, it won't feel like a burden to you. It won't feel very hard to you. So even though it might be hard, it involves lots of physics and maths. It's still it's still pursuable. It's still achievable. That's what I believe. And Reval Akshara asks again, what is the one second? The view is blurred. Ah, what is the function of a nozzle in a rocket? So nozzle is basically responsible for the expansion of gases. Revela. So so there are lots of parts in a rocket. So we have inlet, compressor, combustion chamber, as well as the nozzle. So the nozzle is responsible for the expansion of the gases, which then ultimately reaches the engines, and then from there it is able to function properly. My daughter's friend Satvik. Aruna says my daughter's friend Satvik is very much interested in aerospace engineering. He joined the meeting too. Oh, that's good to hear. Well, hopefully, Satvik, you found this session insightful, and hopefully, you take up aerospace engineering if you're interested in it. I did say it was hard, but I didn't say it was impossible. And honestly, interest defines everything. It supersedes everything, rather. So even though it might be hard, if you're interested, you can definitely pursue it. All the best to you. I'm glad the viewers are asking questions as well, because most webinars are just the speaker just talking non-stop. There's no interactions at all. Those kind of webinars are very boring. But I'm not talking about, not going to specify any webinars, but yeah, it's good that there is interaction from the audience as well. Oh, Deval has another question. It seems like, what is the difference between solid and liquid fuel rockets? The difference is pretty obvious. So each fuel rocket, it consists of a fuel and an oxidizer. So in the case of a solid fuel rocket, the fuel and the oxidizer both are present in the solid form. However, in liquid fuel rockets, they're both present in the liquid form. That's the basic difference. Well, Akshara seems to be quite interested in this field, I suppose. I'm glad to know it. I'm all for it actually. So let's see if anyone has any other question. Sridevi has a question here. What are inflatable modules? Well, as I've discussed in the webinar already, so if space tourism takes off, we'll need orbiting hotels, labs, and even restaurants someday. So these are known as inflatable modules. So traditional metal modules are very heavy and cramped, but inflatable space habitats, like for example, I've discussed Bigelow 330, B330. It is very light, it is expandable, and it can house much more people, and it has very less launch mass as well. So these are still being tested though, and some of these inflated modules are already docked into the ISS. So that should. Okay, Reval Akshara looks like another question. Oh no, it's not a question. I'm also interested in aeronautical engineering, but I suck in physics. Ah, well, definitely physics plays a crucial part in aeronautics and astronautics. And if you're weak in physics, you can still work around it, honestly, if you have the passion for it. Physics is it might be hard, but you can still improve on it. There are still there's still room for improvement if you work nonstop. If you have the passion, I believe anything is achievable, as I've been saying through and through this webinar. And even though you might suck right now, but you might get better. You will get better if you have the passion to learn more. Satvik has another question. What are the main design challenges for hypersonic vehicles? Well, hypersonic vehicles, as we all know, they fly beyond even supersonic Mach numbers. So Mach numbers that are around 3, 4, 5, they're incredibly fast. Main design challenges, I would say, would be the constant provision of thrust. So we need a constant amount of thrust that's backing these vehicles up so that this Mach number is achieved. And the another thing is sonic boom, right? So sonic boom is something that happens when you travel for far too long in supersonic speeds. So that's what happened with the Concorde aircraft, right? So because of the sonic boom, the glasses near the land, glasses of buildings, they started shattering. So that's called a sonic boom. So that's one of the most difficult challenges, I would say, for hypersonic flight. And right now, hypersonic flight, it's not for commercial use at all because it's honestly banned to fly hypersonic over the land. You can only do it over water. So that's another challenge. Hypersonic vehicles, they're still being tested though. So yeah, that's those are two of the most uh, pressing challenges for hypersonic flight.
Thank you, Siddharth. Thank you for sharing valuable insights. Let's wrap up. It's 10 p.m. Thank you, everyone. Thank you for joining Premier Agile events. You can register for further events by visiting www.premieragile.com. Thank you, everyone.